Okay, day 4. The next concept we are going to study basic proportionality theorem. This theorem states that if a line parallel to a side of a triangle intersects the remaining side in two distinct points, then the line divides the sides in the same proportion. As given in the diagram, consider this diagram. This triangle is given there. A line parallel to a side of the triangle. This is a triangle ABC. It is having the three sides: side AB, side BC, and side AC. But the theorem states that if a line parallel to a side of a triangle, this is the line represented by L. Okay, it is parallel to the side BC. Okay, BC. What the next statement state that if a line parallel to side of a triangle intersects means it cuts that remaining two sides of the triangles on distinct points, that is the points are intersection points are P and Q, then the line divide the side in the same proportion. Means we have to prove in this theorem this ratio and this ratio are equal. Okay, this ratio, these two sections and these two sections, ratio among these two sections is equal, that we are going to prove under this theorem. Got this concept? Now let's, what is given? I'm writing here given. As I said you, in theorem you have to write the given. What is the given there? It is a triangle. In which it is given? It is given in the triangle ABC. What is given? Line. Which line is that? Line L is parallel to, line L is parallel to segment BC. Line L is parallel to segment BC. Okay. Then again, what is given there? This line is intersecting AB and AC at point P and Q. It is given in the diagram. Okay. So that we are writing in the given. Okay. Line L intersect segment AB and segment AC at point P and Q respectively. Okay. Then what to prove? We have to prove here. To prove what we are going to prove? We are going to prove that AP by PB is equals to AQ by QC. Well, that is the concept of that. Then the side in two distinct points, then the line divide the sides in the same proportion, that we are proving here. So what we are proving? AP by PB is equals to AQ by QC. So to complete this theorem, we need to do a certain construction over on this diagram. So I'm making that construction. Okay, what I construct? I join the line P to C. I make a connection line between P and C, and I make one line segment here B and Q. Okay, so what I do here? Draw what I constructed. Draw segment PC and segment, which segment? BQ, right? Okay, this the construction is over. Now what we are going to start the proof. How to prove that? Look at the diagram. Look at this triangle. What happens? We got the two triangles with equal height. Which are these two triangles? APQ. Okay, concentrate. APQ, it is one of the triangle, and another triangle we are considering PQB. Okay, APQ1 triangle and PQB is the another triangle. What we are considering there? We are considering this as the height. It is a perpendicular line. Parallel line is always a perpendicular over here, and this is considered as the height of this triangle, isn't it? this part of the triangle, and this is the another triangle we are considering, and this becomes the common height to them. So we know the formula, area is proportion to the bases. Okay, earlier we studied that. So let's start writing the proof. Triangle APQ and triangle PQB have equal heights. Okay, so therefore area of triangle APQ by area of triangle PQB is equals to their bases. What are the bases? It is AP is considered as a base and PB is considered as a base. So AP divided by PB. We are considering that as equation number 1, and this is by the property of areas proportionate to bases. Okay. Similarly, we can use the another triangle. We are considering this with this triangle APQ and PQC we are considering over here. Similarly, same height is there. So we can write area of triangle APQ by area of triangle PQC is equals to, the bases are AQ by QC. We are considering that as a equation number 2, and same property we are using over here. Okay, that is areas proportionate to bases. Okay, now have you observed the diagram? We have written all this by considering this as a common height there. Okay, now this can become the common base for these two triangles. Okay, this PQ we can consider as a base for this triangle, and we can consider the base for this triangle. Here we are applying your homework here, that is third property we are applying, and we are using that one. If the bases are common and heights are common among the triangles, then both area of both triangle is equal. So therefore, if bases and heights are same, then area of two triangles are equal. So therefore we are writing area of triangle PQB is equals to area of triangle PQC. This is our equation number 3. Got it? Okay. So if area of triangles are equal, then the ratios are also equal. So therefore it implies that area of triangle APQ divided by area of triangle PQB is equals to area of triangle APQ divided by area of triangle PQC. This is from equation 1, 2 and 3. Okay. So therefore AP by PB is equals to AQ by QC. This is from equation 1st and 2nd. Hence we prove.